Hi, I'm Vytas Sunspiral. I am a senior robotics researcher in the Intelligent Robotics Group at NASA Ames Research Center. Our NIAC project is to create this super ball bot, an exciting new type of robot that's built out of a tensegrity structure. That's a tension network where all the continuous structure is cables and tensions, and there's individual rods and pieces that are hold it all together. The point of this is to create a landing system that can both act like an airbag. It comes down, it's compliant, it can bounce, and then once it's landed, that very same structure can roll and move and creates mobility on the surface. So now instead of having two separate structures, an airbag you use once and then wheels or other means of mobility, you've combined that to one system. So that saves you mass. Another advantage is that tensegrity structures are packable. You can collapse them because you can reel into coils, and so you can make it into a smaller, compact structure for launch, for getting to whatever planetary or moon that you're going to explore. So we've got two different approaches right now. Both we are developing simulations in a physics-based simulator to really explore both the function of it and the control of it, because that's really the interesting part, is how do you control this sort of elastic, non-traditional structure. And then, yeah, we are starting to build some prototypes. We have two different efforts actually going on, different prototypes that are going to get built. We have traditionally built robots in this very rigidly connected manner, where you have elements that are hinged together with motors. But that's not how we work. There's no pin that holds our bones together. There's no rigid hinge there. In fact, there's a lot of fluidity and a lot of freedom of motion between the bones, and that's well described as a tensegrity structure. The specific NIAC proposal that we have for the super ball bot, for the landing structure, it looks more or less like a sphere. Insofar as that's the outside shape of it, but it's composed of, at the simplest version of it, 6 rods that are all two and two. Each set of 2 is parallel to each other, but then they're all 90 degrees off, and then that's sort of in a network of cables that holds it all together. In the middle of which then is the payload, where we have the science instruments and the power and the computing is held in there, and that's all held by cables suspended in this sort of shell. The ultimate goal of the Super Ball Bot project would really be to have some conclusive demonstrations that this is a compelling architecture for exploration. The benefit of the NIAC program is it really brings validity and support to innovative new ideas. When you integrate many fields, you look like an outsider for any one of those fields, and most funding follows the well-known, well-established bodies of knowledge. So if you want to innovate and disrupt and bring ideas together from many fields, it takes special programs like this who can really see the gems of new ideas and let you run with them.